A few other points I want to make about industrialization that at this stage, much of what is defining industrialization is not so much the application of technology, although as you see in textiles, that can certainly be the case, but rather it's a dramatic revolution in the work process itself. And it goes by a particular three-word phrase, the division of labor. This is not a new concept at this time. Adam Smith wrote about it in The Wealth of Nations back in 1776 as he was observing England's takeoff, its own industrial revolution. But it's really key to understanding the transformation of how work operates at this time. So here's one example of this, of how the world is transformed at this time without necessarily the advent of anything special, that is to say, labor-saving machinery. So prior to 1820, most clothing was still sewn at home by women. The wealthy might have tailors who made custom bespoke clothing for them. But in the succeeding decade, ready-made clothing, ready-to-wear clothing, like off-the-rack clothing, became increasingly common and ubiquitous. While some of it was made in centralized factories in places like New York or Massachusetts, much more was made using this hybrid system that I've talked about, where people worked from their homes and participated in this larger industrialization process, but did so in this disaggregated way, using this concept of the division of labor. So for example, in the case of ready-made clothing, instead of a tailor making a piece of clothing from start to finish, or a woman at home making a piece of clothing for her own family from start to finish, instead, a kind of semi-skilled tailor would perhaps cut the panels out for the shirt or coat, and then this would be distributed to women seamstresses working at home, whose job it would be to sew and sew and sew exactly the same thing over and over. And by virtue of dividing up the labor, you were able to get economies of speed as people mastered a task, especially if you paid them by the piece. They had an incentive to do as quickly as possible. And then those pieces could then be either sewn together one side or pieces joined, and the system could kind of like move parts from in a decentralized way out to be sewn and then bring them together again. So to give you an example, by the late 1850s, a single pair of pants typically took 17 different people to assemble, but it was oftentimes done in this way of this, you can see this poor woman here working in New York City, a seamstress, who might take one of those pieces and finish them and sew the button on and hand it back and then go to someone else. So there's a great division of labor. The other place where you really see the division of labor is with the manufacturing of shoes. Again, a lot of the work gets outsourced to people like farmers in their homes who might sew the soles on or the uppers, what have you. But you did it in such a way that you could use semi-skilled or in some cases even unskilled labor to do very simple stages in the production process. That's why the division of labor is so powerful, because on the one hand, you get economies of scale by just having the same task repeated over and over. At the same time, a lot of the kind of overarching skill, the years of training that it takes, you don't need it, because if one person only does one task, they can be trained up on that pretty quickly, all right? So in the case of shoes, you again had an employer, a capitalist basically, who would buy the equipment and the supplies. They would hire semi-skilled journeymen who were not master shoemakers, had them cut up the leather into soles in the upper part of the shoe, and then send them out to be sewn together, or rather sent out to women to sew the liners in, and then other journeymen would assemble the shoes and return them to the central shop for inspection and packaging. So it's this really kind of odd spread out system that nonetheless is very efficient, much more efficient than a master bootmaker or shoemaker making a pair of shoes from start to finish. The other thing that's noteworthy about these systems, and you see it in the case of seamstresses making clothing in a place like New York City, you see it in bootmakers in Lynn, Massachusetts, is that there are many manufacturers all clustered together. Again, this is a very typical feature of early industrialization, where it makes sense actually for competitors to locate next to one another because they can all compete for the same supplies and the same labor force. And there's a certain efficiency to that because people who say want to work in the shoe industry can go sell their labor on the open market in this one city where most of the shoes are made. Flip side, or the downside, is that there's tremendous, sometimes cutthroat price competition. And the only way to get the upper hand here is to drive wages down, try to get the material more cheaply, try to figure out how to divide up the labor even more effectively and expeditiously to make more money. On the flip side, on the plus side, you do have a growing amount of actually useful ready-made clothing, though it's worth pointing out that the first generation of ready-made was pretty crude, kind of one size fits all. But you start to see at this time the beginnings of some quite legendary retail names like Brooks Brothers, for example, who begin to build connections between the factories that are making the goods or the systems of labor that make the goods and the actual retail stores that produce them. And in some cases, these will produce fairly significant fortunes for these entrepreneurs. One of the more famous is a man named Paul Tulane from New Orleans, who actually capitalized a New York factory and sold goods in his Louisiana store. And that was the beginning of the fortune that built Tulane University. So this is a much later image. This is after the Civil War, but I like to show it because it shows just how effective and important division of labor is and how it can be applied to so many different things. This is a slaughterhouse in Cincinnati. They were using this method before the Civil War. And in it, the slaughtering of hogs and dismemberment of the carcass and the rendering of the fat and all of the different kind of gruesome pieces of this process are shown here, and it is a division of labor in which individuals on the assembly line, or in this case the disassembly line, are taking and doing the same thing over and over and over as quickly as humanly possible. Interestingly enough, this was the model that would ultimately inspire or help inspire Henry Ford to create the mass production assembly line in the 20th century. So for all of that, Ford is a good segue to talk about the one set of innovations that are going to increasingly define what we would describe today as high-tech industry in the 19th century. And this is what is known as the American system of manufacturing. And this is genuinely a distinctly American contribution to a problem, and one that goes well beyond the simple division of labor, which the British had already played with and perfected. Credit for this idea goes to this man here, Eli Whitney, a Yale graduate and inventor who contracted with the federal government in 1798 to make 10,000 rifles in 20 days. This was, at the time, considered to be an astonishingly fast manufacturing turnaround. Like many defense contractors, though, he didn't deliver it on time. It took him 8 years. But in the process, he refined and ultimately built the system of interchangeable parts that is going to increasingly define mass production in the United States. So what are interchangeable parts, and why is that so important? Well, up until this time, until Whitney, when you made a gun for the federal government or for a private customer, every single rifle was made by a gunsmith from stock to barrel as a kind of unique piece. I mean, it might resemble other guns, but no one remotely expected a piece or part from one gun to be operable and insertable into another gun. And so Whitney's idea was that he would make guns in which the pieces were functionally identical, absolutely identical, and that therefore they could be swapped out. And in the process, it would be very easy to, say, make repairs. And because an idea was forming in his head of how to do this, it was going to also be more efficient as well to produce a huge number. So what he did was he designed a rifle, like, you know, an actual, like, imagine a blueprint. And then for every single part of the gun, whether it was part of the wood stock or trigger, what have you, he made a template. And it was very similar in principle to like a dress pattern, you know, where you have this one uniform thing that you use to trace out parts, and then you design each part and mill it out so that it is identical functionally to the others. And if you think about how this might work with the division of labor, if one person is just producing one part, you can produce a lot of parts relatively quickly. He had to, though, in the process of devising this system of interchangeable parts, come up with a lot of different machines that would be making consistent metal parts and allow them to be replicable. And this required immense amounts of mechanical skill. And even when he was done with this, he still had to fiddle with some of the parts to make them fit together. By the 1820s, this system that Whitney had introduced had spread to a variety of firearms manufacturers, in part because the United States Ordnance Department, that was responsible for procuring firearms for the military, increasingly insisted on this. And they did so for a very good reason, because they knew very quickly that this conferred a huge advantage, that each gun could be used interchangeably and that you could order spare parts. All of this may seem so fundamentally obvious and like, why wouldn't you do this? But at the time, this was a truly revelatory concept. You know, today, if, say, you're driving your car and you get into an accident on Millage Avenue and you take it to the body shop, they just order the parts. The parts are mass produced. They're absolutely identical one another. They just drop in the new parts, boom, you're done. That concept, well, it begins here, all right? So Whitney's concept of these interchangeable pieces begins to spread to other kinds of mass-produced consumer goods, no longer just the federal government as a client and customer, but others as well. And this goes hand in hand with the development of increasingly sophisticated metalworking machines, machine tools that are going to catapult the United States in an increasingly enviable position as a manufacturer or mass producer of everything from steam locomotives, shown here, to even more delicate instruments like this pocket watch. This pocket watch, incidentally, is not a handicrafted item that is a bespoke item. It is a mass-produced item made in Massachusetts by the Waltham Watch Company, whose wares are shown here. And while we may treasure these as antiques, they were made in precisely the same fashion as those rifles in Whitney's arsenal works. They were made, in other words, with the idea of a high volume production using interchangeable parts and wedded to the division of labor, which relies on semi-skilled, sometimes semi-skilled workers. Incidentally, too, if you look here at the Waltham Watch Company, you begin to see by the 1850s the intrusion of steam-powered, fired by coal or wood, as a means of energy. Very, very different than the early hydropower, but much more reliable and consistent, even though obviously it's a bit more of a problem when it comes to carbon dioxide. So all of this is really kind of remarkable if you think about it in retrospect, because there's this tremendous ferment of invention. What had initially been only a handful of patents filed in the new nation the first year the patent office opened, begins to see hundreds of new patents filed every single year as growing numbers of inventors, mechanics, as they were sometimes called, machinists, industrialists, begin to try to develop increasingly sophisticated forms of labor-saving machinery, machinery that works well in promoting the American system of manufacturing. And interestingly enough, like it was in these kinds of venues, this is what's known as the Franklin Institute in Philadelphia, which was a kind of association of practical men who were inventors, mechanics, scientists who were interested in finding applications for their refinements on existing technology. And so it was mechanics institutes like these that helped play a role. And then it was, of course, the patent office itself, which is what recognized intellectual property and conferred the imprimatur of the US government on them, and then allowed those manufacturers or inventors to profit from the proceeds of their invention at this time. And some of these inventions, like the one on the right, this is Abraham Lincoln, our former president, you may have heard of him, even he came up with an invention that was actually patented, which was an idea of how to get boats over shoals on the Western rivers. Not so significant in terms of its commercial application. In fact, most patents are. The patent on the left, though, enormously important. It was Isaac Singer who patented a mass-produced sewing machine that was made with interchangeable parts, very easy to repair, affordable and within reach of even in some cases working class families, and it was run. You would basically pedal it with your feet and tapping so that it would run, and it allowed people to sew clothes at home, or it could be used in a factory. And these are the sorts of machines that are increasingly coming to define American technological supremacy. Here's the Singer sewing machine in 1851. I show it because in 1851, the United States kind of burst into global consciousness as an important manufacturer in its own right, and a genuine competitor to Great Britain. This is when something known as the London Crystal Palace exhibition took place. It was an international exhibition in which countries all around the world brought the best things that they could offer as evidence of their own ingenuity and economic advancement. And the United States brought a number of machines that really stole the show. These went from everything from the McCormick Reaper to unpickable locks to Samuel Colt's revolver to the rotary printing press that was used. Here's Colt's revolver, which was a mass-produced item made in Hartford, Connecticut, one of the major industrial centers of the first half of the 19th century. And appropriately enough, Colt and firearms really came to define a lot of what America stood for. Not because of the violence, but because of the mass-produced nature of these weapons that put them within the hands of ordinary individuals. Note that the patent date on this is 1850, so 1 year before the Crystal Palace exhibition. One last sort of story or interesting aside about this is that these concepts of mass-produced wares that relied on interchangeable parts would ultimately attract British dignitaries to visit factories in the United States, and including go to the Springfield Armory in Massachusetts, which was one of the major sites. It was controlled by the federal government, but where guns were assembled and tested. And in this particular instance, when they visited in the 1850s, the Americans put on a demonstration for them that's quite memorable for what it showed. They took weapons, rifles, disassembled them, and put each piece in its own box. So, if they had 20 rifles, they would have had, 20 gun stocks, 20 barrels, 20 triggers, so on and so forth. And then they mixed them up and they reassembled them from the disparate parts, just a new gun. So basically they randomly mixed the parts together and the guns fired and the guns worked. And for the British, this was astonishing that this had been accomplished, but this was the magic of the American system of manufacturing.